Okay, Jai Hind to everyone. Myself is Dr. Shashank Sahu. Today I am going to present the topic Lambda expression and functional interface. Basically, this topic is under the subject object-oriented programming with Java and under the unit 3 Java new features, and subject code is BCS 403. The first question is what is the Lambda expression? Basically, it is a method we call as a unnamed method. Sometimes it is also called anonymous method. And this lambda expression is not executed in its own. Generally, you are aware that when we create a method, we call the method to execute it. But in case of lambda expression, it is not possible. It is created but cannot be executed. Then what is the approach to execute this method, that is lambda expression? It can be executed with the help of functional interface. To learn the topic of lambda expression, we need to learn the functional interface also. So in this slide, I discuss functional interface also. So in brief, we talk about lambda expression is nothing else, it is a method. Only it is different from the traditional method is that no name is given to this method. Let's we talk about the functional interface, which is important to execute the lambda expression. So functional interface, basically it is an interface. I assume you know about basics of the interface. So not going to discuss in detail what is the interface. In this video, my focus will be only in the functional interface. So it is an interface and it has only one abstract method. That is only one method. So functional interface is an interface that consists of one method. This is the method which is for the intended purpose of the interface. So we call as a functional interface is for only one specific purpose. If you want to execute one action, then we make an abstract method for that action and put it in the functional interface. One of the example for the functional interface is runnable interface. This runnable interface is used in the multi-programming. So runnable is the functional interface and it consists of only one method is called run. So because of runnable interface consists of only one method, we call as a runnable interface, as a functional interface. Next, have an example about what is the functional interface. Look for the implementation. To define any interface, we write the interface here. Then we write the name of the interface. Next, I have to write a method in this interface. So one method is given get value, and it is an abstract method because it is ended with the semicolon. This method will return a value. The type of the return a value is double. So it is a very basic example to define a functional interface. It consists of only one method. Name is in this example is get value, and it is an abstract and it is returning the value of double. So functional interface basically define a target type for the lambda expression. To execute a lambda expression, you must define a target type on which the lambda expression will be executed. So we combine lambda expression with the functional interface. The target type for the lambda expression for execution is the functional interface. So lambda expression can be used only in the context in which its target type is specified. Here you can say in a different way. One is lambda expression, second is functional interface. Both are related somehow. Then with the help of functional interface, we execute the lambda expression method. Functional interface sometimes is also referred as SAM type. Meaning is single abstract method. At its defined in functional interface definition, it is an interface that has only one method. So, it is just a brief of functional interface. Now, there are some important points related to lambda expression that we need to learn it just for the understanding purpose, and just to remember again, lambda expression is not executed on its own. Rather, it forms the implementation of the abstract method. So, recently I have given a abstract method get value. So, we can give the implementation of abstract method with the help of lambda expression. And this abstract method is defined in the functional interface. As a result, lambda expression can be specified only in the context in which a target type is defined. One of these contexts is created when a lambda expression is assigned to a functional interface reference, that I will see in the example. We have a lambda expression, we have a functional interface, then we define a reference variable for the functional interface and assign the lambda expression to the functional interface reference. That will give the implementation of the abstract method, which is already defined in the functional interface. Now, it is not only the way to execute the lambda expression. Lambda expression can be executed in many different target types also. So, other target type context includes variable initialization. So, lambda expression can be used for it. It can use to return the statements and it can use as a argument also. So, the use of the lambda expression is a very different way. One of the use is to define the implementation of abstract method. Other way we can use the variable initialization. If you want to return a value, that is also possible, and it can be used to pass an argument also. Next, look for example. I already defined a functional interface. Name of the functional interface is by number. Here you can see I have defined a variable of my number. Basically, it is a reference variable of my number. Now, this portion is very important. Here you can see it is a lambda expression that I will give you in more detail how to write the lambda expression, and it is a reference variable of the functional interface. Just use the assignment operator, assign this lambda expression to this reference variable. What is the meaning of this statement is that it gives the implementation of the abstract method, which is already defined in the functional interface, and name of the abstract method is get value. So, here you can see we have given the implementation for the abstract method of get value, just assigning the lambda expression to the reference variable. Now, I will go in detail in some slides how to define the lambda expression. Now, this is just an explanation about the previous slide. After assigning the lambda expression to the reference variable of functional interface, we can just use the get value method. I already told it was an abstract method. After assigning the lambda expression to this reference variable, get value get the implementation, and the implementation is very simple, just return a constant value. So, when we call the get value, it will return a constant value and the constant value will be displayed. The constant value is 123.45. Just clubbing all this thing in one program. So, you can see we have a functional interface, my number, and we have given a get value and abstract method. Then I defined a class of lambda demo because of Java programming. Then we have a main method. So, in the main method, we have created a reference variable of functional interface, then assign the lambda expression. This is the whole is called the lambda expression. It is basically returning a constant value is 123.45, and we are executing the get value method. When we call this get value, it will execute the lambda expression, and it is also possible assign a different lambda expression to the same reference variable. So, this point is a very different. Here you can see the lambda expression is this one. This is the lambda expression. Here we are executing a random number and multiplied by 100. So, this time the execution of this get value will be different after assigning this lambda expression to this reference variable. Now, when this expression is assigned to this functional reference variable, now the execution will be according to this lambda expression. So, here when we call the get value, its implementation has been changed. This implementation will get the random value and it will be multiplied by 100. And again we calling this get value, obviously because of the mat.random it will give a different random number and multiplied by 100. Now again very important part, this is a very important, it is in comment, you can see it is in comment just for the explanation purpose to you. Here you can see the lambda expression is given. In this lambda expression we are using the string format. And if you look for the format of abstract method is returning the double value. So, this lambda expression cannot be used because it is a string type and we want the return type of should be double. So, one important part for understanding in this program is that when we assign a lambda expression to a functional interface abstract method, its compatibility should be same. That is, if a abstract method of a functional interface is returning the double value, then we can assign only those lambda expression in which it returning the number. So, here it is not returning the number, it is returning the string, therefore, it is an error. So, these are the output, here you can see because it is in a comment. So, there is a no output for this one, it is for your understanding purpose. Here you can see it is returning a value 1, 2, 3, 4, 5, A basically is the part of here, that is a random number value. So, it is a random value, it is another random value, this output is given here. So, I discuss about this program and in detail it is explaining what is the functional interface in detail and some idea about the lambda expression. I will go in detail about how to write the lambda expression and this is the output. So, basically up to this slide I discuss about what is the functional interface. Let us we have one more example demonstrating the functional interface. Now, here the name of the interface is numeric test and name of the abstract method is test. Here we are taking a value n and this abstract method is returning the data of type boolean. Now, we have a class, then we have a main method, then we have a created or you can say a interface reference variable. Then we write a lambda expression, this is the lambda expression. This lambda expression is receiving a value, a parameter that is n, then we are making a subcalculation to find out whether a value is even or not. If n modulus 2 is equal to 0, the value is even. If this condition will satisfy, it will return the value. It will check whether the value is even or not. So, it will return the boolean value, true and false. So, is even is the reference variable, test is the abstract method, this is the functionality implementation of lambda expression that we assign to the is even reference variable. Now, we call the test method because now it get the implementation with the help of the lambda expression. We pass the value 10, it will check it, if it will return the true, so it will display that 10 is even. If we pass the value of 9, again it will check, if it will return the 9 is not even number because we are using not function. So, it will reverse the boolean value. So, it will return the false, it becomes true and will display the message 9 is not even. So, it is a very simple example, remember here exclamation sign here. So, this is again an example of functional interface and one more change is there. We can assign, again we take in a different reference variable of numeric test, that is functional interface, and we assign the lambda expression here. this lambda expression is just checking that whatever the value n is greater than equal to 0 or not. If the value 1 is greater than equal to 0, it will be true, it will display 1 is not negative. And if any value like -1 is basically it is a negative value, the condition will not satisfy, it will return the false, and after the negation it will be true and will display -1 is negative. So, here we have get a glimpse of what is the lambda expression and how to assign the lambda expression to a functional interface abstract method. 10 is even, 9 is not even, 1 is not negative and -1 is negative. Next we go in the lambda expression in detail. How will you write the lambda expression? Lambda expression is written with the help of lambda operator, which is also called arrow operator. Arrow operator, that is lambda operator, divided into two parts, the left side and the right side. So, left side we can give any parameter required by the lambda expression. If no parameter is needed, then we give empty parameter list is used, that is we just use the parenthesis. Right side is the lambda body, which is specified the action that is needed in the lambda expression. So, important here in this slide is to write any lambda expression we need to this arrow operator. So, arrow operator can be also called as a becomes or goes to. So, in this slide is simple thing to understand. To write the lambda expression, there must be an arrow. This is the left side, this is the right side, we call as a L, we call as a right. L, here we write the parameter in the parenthesis. Here R is for writing an action. Action can be anything, as in the previous slide we can write 123.45, it is a constant value, or we can write like this way. Here we are not using the parameter, we are here the P, we can write anything, for example like P into 10, you can write any expression here. So, that will return accordingly. So, important to understand here, the arrow will give the left side is the parameter, right side is the action. Here you can see back side. Here you can see this is the lambda operator and n is the parameter, it is a parameter, and this part is the action part. Any action you can write here. So, here action is just to check whether the n is greater than equal to 0 or not. If n is greater than equal to 0, because it is a relational operator, it will return the true and false. If this condition will satisfy, this lambda expression will return the true. If this condition is not satisfied, this lambda expression will return the false. So, it is an example how to write the lambda expression. So, up to this slide our understanding is that to write any lambda expression, we need to use the arrow operator. This is arrow operator is important. Now, right side, that is we are talking about the right side. Can we have two category? One is of single expression, second is for the block. Single and block, we are talking about the action part, we are talking about the body of the lambda expression. Basically, right side is called the body of the lambda expression, left side is called the parameter of the lambda expression. So, the body can be of two type, one is single, second is block of the code. Now, in the single expression, we have only single statement, therefore, it is called the single expression. So, if a body of the lambda consists of single expression, this type of lambda body is referred to as expression bodies, and sometimes it is also called expression lambda. So, this code right side has only single expression. It is an example. This is a single expression, one statement. Single expression meaning is one statement. So, it is a lambda operator. This is a left side, this is a right side. right, left side there is a no parameter, write the parenthesis blank, right side there should be action, action is only a constant value and there is a one statement, therefore it is called single expression lambda expression. We can say, yeah, expression lambda. One more example of single expression lambda is, this is the lambda operator, it is a lambda operator, it is a right side, it is a left side, it is a parameter, there is a no parameter, and basically it is an action, it is a action. So, action we have a one expression, we calling a random function of the math class, whatever the random value will be written, it will be multiplied by the 100 and that multiplication will be written as a return value. One more example is, we have a single parameter n and this is the action, left side, right side, it is an action. Action is what? It is a single expression, n percentage by 2 equal to 0. It is just checking, that is n modulus 2 equal to 0. Then we talk about in brief what is the black lambda expression. In the block lambda expression. In case of block lambda expression, we can have more than one statement, that is a block lambda expression. So, these are some statements that you can read. Basically, it is used in many other purpose. So, I am just going to discuss the example. I have the slide is for your understanding purpose. So, example of block lambda expression. So, we have a functional interface, one function, we have a main method and this is the functional interface variable, okay, reference variable, and we are using the lambda expression. Now, left side is a one parameter, right side is a parenthesis. So, whenever we are using the block lambda expression, action part must be in the curly bracket. Again I am repeating, for the block lambda expression you must have the parenthesis, all the statement will be within the parenthesis. So, starting of the parenthesis, then we have given the logic result equal to 1, we have given the logic to find out the factorial of a number, because we are making the action to find out the factorial of a number. Then we are just use factorial is the functional reference variable and we call this function is the abstract method. Its implementation is given with the help of lambda expression, that is with the help of block lambda expression, and we are passing the value 3. 3 value will be received here and it will be executed with the help of this logic to find out the factorial of a 3. Again we are passing the value 5 in this function and its implementation is already given with the help of this lambda expression, and we are using the block lambda expression because more than one statements, that is why we are using the parenthesis and it will display the factorial of number 5. This is the output. So, till now I have discussed about what is the lambda expression, what is the functional interface, and I have given a brief idea about the functional interface, and I discussed in this video I discussed mainly about the lambda expression. So, basically at the starting of the slide I discussed what is the functional interface with few examples. Then I go in the detail about what is the lambda expression, and basically there are two types, one is single expression and second is block lambda expression. Block lambda expression meaning is more than one statement, so there must be a curly bracket, and in single expression there is no need for any curly bracket. Arrow is the lambda operator and it has two sides, left side and right side. Left side is for the parameter and right side is for the action part. Thank you very much.